1 minute to launch. Let's just fly through the ignition sequence here. It's a little bit different from Ariane. We have first a low thrust level, then intermediate, and then full. What's that about?
Yes, exactly. All the engines on the 4 boosters on the core stage will be ignited at the same time. As soon as the launch command will be sent on 20 seconds before the launch. And they initially operate at a low level. And afterwards you will have... we have
and there goes the KZM mast.
Yes.
Bang on time.
So everything is nominal until now. And finally, after...
Attention pour le début de la séquence d'allumage de lanceur.
Beginning of the ignition sequence. Right, everybody, we shall let you watch the launch. Best wishes to everyone.
Allumage du triétage. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, décollage.
Wow, always spectacular. We're off, heading out over the Atlantic Ocean. We're burning 5 engines, 1 on the core stage and 4 on the boosters. The boosters, though, are the ones that are doing all the work here because their job is just to haul us against the gravity of the Earth. Tell us about them.
Yeah, the boosters are providing 80% of the thrust right now. There are 4 identical conical shaped boosters strapped to the second stage. And the RD-107A engine is powered by the liquid oxygen and kerosene. That's the same propellant used for the 3 main stages of the Soyuz. And each engine has 4 combustion chambers and nozzles.
And we're getting some spectacular images here as we fly through the Earth's atmosphere. We can see there the trace of the propellant.
We are very lucky because we have a daylight launch and we can see it until very high in the sky.
And if we're really lucky, we might get to actually see those boosters falling away in real life. So the launcher is sending us telemetry signals, and here we go. We're getting the booster cutoff, and we can actually see them. Those 4 dots on the screen. There they go, flying away.
The 4 boosters.
Heading back down to Earth. So tell us what we're looking at on the left-hand side of the screen.
Yes, on the left side of the screen you have in fact the predicted trajectory profile, and you have the dot on the curve, which is the actual position of the launch vehicle.
Les paramètres bord sont normaux.
Everything is nominal on board, so good news. And the A stands for the altitude, so we are now at the 68 kilometer, and the V for speed.
And we're now burning the main core stage, or the block A, and that burns for just under 5 minutes.
Yes, the block A is...
propulsion est normale.
Everything is normal. The block A is a hammerhead shape to accommodate the boosters. It's composed of 2 huge tanks of propellant, LOX and kerosene, and the propulsion is provided by the RD-108A engine. You have already... as for the boosters... 4 combustion chambers, along with 4 vernier thrusters.
And the fairing we're looking at here at the top of the vehicle, it's got the satellites inside and it's protecting them from the rigors of the launch, isn't it?
Yeah, it protects the satellites from external environment first on ground, once the satellites are encapsulated, and then during flight, protecting them from different fluxes and aerodynamic pressure and heating with dense atmosphere. As soon as the aerothermal flux becomes lower than satellite acceptable value, the fairing is jettisoned.
And of course we are flying through the dense atmosphere of the Earth, which is roughly about 100 kilometers thick, and as we get to the outside of the atmosphere, the friction is reduced and the satellites are able to bear it. So we're now having the predicted images there of the separation of the fairing. We don't need it anymore because we don't have much friction left anymore. Thierry, with the images that we're seeing, we can still see them down here on the bottom left-hand side of the screen. These are images which actually you created right from the start, aren't they? They're simulated images of what is actually happening?
Yes, in fact, I was at the origin of this 3D dimension simulation program, and all the 3D images that you see are simulated ones, but all the movements and positions are based on exact nominal prediction of the launch. So all the parameters are normal. Good news. There is today no correlation with real telemetry coming from the launcher, but one day, perhaps, I hope that we will get it.
That would be good. So what we're looking at here is the second stage, Block A, the third stage with a latticework connection in the middle, and the satellites there are exposed to space, and we're now getting the prediction of the second stage separation. We're seeing all these milestones happening at the right time, but we get the actual confirmations slightly later, and that's perfectly normal. It takes a little time for the information to get to the range operations manager, and then, of course, he'll call out the confirmations when he gets them. So what are we looking at here? It's a peculiarity of Soyuz, isn't it, the way the engines are ignited?
Séparation du bloc A.
We received the confirmation of the separation, which is fully nominal. Yes, you're right. With Ariane, we separate one stage before ignition. Next, with Soyuz, there is a specificity with the third stage ignition. It starts approximately 2 seconds before the previous stage shutdown. And the thrust from the third stage engine at ignition helps to push the second stage away. And the second and third stage, they are linked by a latticework structure to help evacuate and enable us to ignite the engine before separation.
And that was the structure we could see linking the two stages. And how do we separate them? How does it work?
We use pyrotechnic locks and spring pushers to push the stage away.
So we're now burning the third stage. It burns for about 4.5 minutes. What's our speed and altitude?
Now the altitude is roughly at 175 kilometer and the speed velocity at 4.47 kilometer per second.
And we're looking here at the frigate is the gold section, that's the upper stage, and the satellites attached. This is the 7th launch so far this year from the Guyana Space Centre, and we're preparing 3 more. It's been a busy time.
Ariane 5 sets another record, the 54th successful launch in a row. On the 28th of September, it orbited 2 satellites, Astra 12 for the Luxembourg operator SES and GSAT-10 for the Indian Space Research Organization.
During the 63rd International Astronautical Congress in Naples in October, Arianespace reaffirmed its position as the world's benchmark launch service provider and a partner to Italian space industry. Italy plays an important role in the launch family, as well as building satellites.
Activities at the CSG are scaling up. On the 9th of October, the next Ariane 5 was transferred to the final assembly bidding to launch Eutelsat 21B and Star 1C3 on the 9th of November.
The 4th automated transfer vehicle, otherwise known as Albert Einstein, is undergoing preparations. Europe's cargo ship is due for launch to the International Space Station in April 2013.
Activities for the 4th Soyuz launch from the CSG have started, and this week preparations are taking place on the frigate boost stage to launch the second Pléiades satellite on the 30th of November.
And activities for Vega's second launch under the Verte programme are to start at the end of November, with the transfer of the P-80 first stage to the launch zone.